Hey guys, so this is going to be a video to explain the answers to your 5-7 general solutions worksheet. I'm not going to do every question, so you won't get all the answers, but you have your solutions right there. I'm going to do questions 4, 5, 8, 10, 11, 14, and 15. And then for honors, I'm going to do 17 through 20. So academics can stop after 15. If you don't need all those questions, just jump around in the video. And the reason I'm doing those questions is just that I felt like they were the hardest and kind of represented a cross-section of the different types. So let's start with question 4. In question 4, step 1 is going to be to get that cosine alone. So we have cosine of theta is 0. Now, if you put this in your calculator, inverse cosine of 0, it's going to tell you the answer is 90. Now, think about your unit circle for a second. Here's 90, and we know that the cosine right there, the x-coordinate, is 0. So that's one solution from 0 to 360, but now we have to consider, are there any other solutions? So the other place that we can see that the x-coordinate would be 0 is right down here, and that's 270. So our two answers are 90 and 270. Let's move on to question 5. So question 5, our first step is going to be to subtract 4 from both sides. And this looks like a big mess, but your calculator can sort it out. So you can do inverse cosine of the whole thing. So 8 minus root 3 over 2 minus 4. Now, if you're pretty good at fractions, you might have noticed that subtracting 4 is the same as subtracting 8 over 2, which makes the 8 over 2 go away. So if you did that sort of in your head, you would have ended up with negative root 3 over 2. Okay, and then in knowing the special right triangles, what angle has a cosine of root 3 over 2? That's 30. But since it's negative, we have to remember that when cosine's negative, from 0 to 180, that's over here. So here's our 30 that we're looking for. And that's actually an angle of 150. So your calculator will return 150 here. Now, the other place that we could draw this 30-degree angle is right here. It will also have the x-coordinate of negative root 3 over 2. So what angle is that? It's 180 plus 30. So our other possibility is 210. So 180 plus 30 gave us this other angle. So 210 and 150 are the answers. Number 8. Okay, let's start again by adding the 4 to both sides. All right, and if you are really fraction savvy, with a denominator of 3, 4 would be 12 over 3. So this sort of 12 over 3 part goes away. So we're going to end up with tangent of negative root 3 over 3. And if you didn't know that, that's okay. Just do, inverse tangent of that. So if you didn't know that, it's okay if you can't work that part of the question. Just put it all in your calculator together. I should back up and mention that I'm going to treat this theta plus 120 as x for now. And then I deal with that at the end of the problem. So remember, this 120 is a phase shift. So that sort of shifts everything off to the side, but it doesn't change the period. So I know that the inverse tangent of basically this whole thing right here, so negative 12 minus root 3 over 3 plus 4 is going to give me negative 30 in the calculator. Okay, so let's think about that. Here's my negative 30 right here. Now, where else can I draw this angle to have the same tangent? So with tangent, we can just extend the line. 30 degrees right here. So right now we know that x equals negative 30, but that's not between 0 and 360, so I'm probably going to ignore that solution. And 150, because the angle that I just drew is 180 minus 30. And then also 330, because if I go around the circle from here to here, here to here, that's 330 degrees. So my other possibility is 330. So that's what x is. Now I know that x is theta plus 120. So now I have to sub in theta plus 120 for x. So I'm going to ignore this one because it's not in my 0 to 360 domain. So I'm going to go theta plus 120 equals 150. So that's one possibility for theta. So subtract 120, and I get 30 degrees. So theta is 30. That's one possibility. Another possibility for theta is 330. So theta plus 120 equals 330. Now I just need to solve that equation. So subtracting 120 from both sides, I get 210. So the other possibility for theta is 210. Okay, let's move on to question 10. So in question 10, we have another situation of having a phase shift. So I'm again going to treat the phase shift, that whole section, just as x. I'm going to subtract 5 from both sides. So I have sine of x equals negative 1. Now, this is kind of an odd case. So again, you can go inverse sine of negative 1, and your calculator will spit out an answer. If you remember the unit circle, the only place where y is negative 1 is right down here at 270. However, your calculator only recognizes the answers from negative 90 to positive 90 for inverse sine. So that would also be considered negative 90. So your calculator is going to tell you negative 90. So the problem is negative 90 isn't in our domain of 0 to 360. So what I'm going to do to put it into that domain is I'm going to add 360 and get 270. So if you were using the unit circle to begin with, you already had the 270. If you're using your calculator, you needed to add 360 to get that 270. So we know that x equals 270. Now we have to replace x with theta plus 150. So we're going to go theta plus 150 equals 270, and then subtract 150 from both sides. So theta equals 120. There's only one answer for this question. All right, number 11. So 11 starts to get into radians here. So the way you know you're in radians is in the directions it said solve each equation for 0 to 2 pi. So 2 pi tells me that we're in radians. So the only thing that changes is that your final answer is in radians. You can do the whole thing like we were just doing and then change it at the end if that's what's more comfortable for you. So let's start by adding 1. So we have the inverse sine of this whole thing right here. So negative 2 minus root 3 over 2 plus 1. So our calculator is going to give us negative 60, or an answer there. All right, now let's draw negative 60. And let's think about where else we could draw 60 and have the sign be the same. So the sign is the y, which means it would be right over here in quadrant 3 that I would draw that 60. So the two angles that I would be looking for from 0 to 360 would be this angle that goes from 0 all the way to 60, so that would be 180 plus 60, so that's 240. And then the other angle that goes from 0 all the way around to 60 below, which is 300. Now, your answer has to be in radians. So, you can go 240 times pi over 180, and then reduce this fraction, and you will get 4 pi over 3. And then you're going to do 300 times pi over 180, and you will get 5 pi over 3. Now, if you're pretty good with radians, you might have recognized that 60 is negative pi over 3. So instead of having your angles in degrees on your circle here, you could have had it in radians. So this would have been negative pi over 3, and I'm drawing pi over 3 over here. So I know that from here to here, that's a full pi, so 3 pi over 3. So I'm adding pi over 3, and that's what gives me my 4 pi over 3. And over here, on the right, 360 would be 6 pi over 3, and I'm subtracting pi over 3 from that, and that's where I get the 5 pi over 3. So you can do the whole thing in radians from start to finish if you'd like. Okay, number 14, another radian question. So the first thing I'm going to do is I'm going to divide both sides by negative 4. Actually, the first thing I'm going to do is switch colors because this one's kind of hard to see. Okay, dividing by negative 4. So what that will do is cancel that out right here. So now I have tan theta equals root 3. So I know I need to do the inverse tangent of root 3. And if you think about your special right triangles, what angle has a tangent of root 3 over 1? That angle is going to be 60. But you could also do it in the calculator, and the calculator will give you 60 as an angle, which is pi over 3, as we just discussed. So let's think about the unit circle for a second. Here's my 60-degree angle, also known as pi over 3. And where else can I draw that angle with the same tangent? With tangent, you just extend the line. So pi over 3 down here. So our two answers are going to be pretty straightforward on this one. One of them is just pi over 3. Pi over 3 is between 0 and 2 pi. So 60 degrees, pi over 3. The other one is going to be 180 plus 60, which is 3 pi over 3 plus a pi over 3. So 4 pi over 3. So there's your two answers. Okay, let's look at 15. So for 15, it's asking you for all the solutions between 0 to 2 pi in radians to the nearest thousandths. So the first thing you're going to want to do is make sure your calculator's in radian mode. And then we want to remember, if we were to draw the unit circle in decimal radians, which is really awkward, but it would be a 0 here, and this being pi over 2 on top is going to work out to be 1.57. And then here, this is pi at 180, so that's 3.14, and that's probably all we need. So the first thing we're going to do is the inverse cosine of 0.72. And that's going to give us 0.767 radians. If you didn't get that answer, it's because you weren't in radian mode on your calculator. So in the unit circle, that would be right about here, 0.767, because we're between 0 and 1.57. Now, where else can I draw an angle and have the same cosine? Right below. So one possibility for an answer here is 0.767. That is between 0 and 2 pi, 6.28. The other possibility is going to be 6.28 minus 0.767. That gives you your other angle right over here. And that is 4.712. So 4.712 and 0.767 are our two solutions between 0 and 2 pi. Give a general solution to the equation. So this part deals with the fact that we know that the cosine of an angle can be 0.72 many times. And of course it will be when the angle is 0.767, but it's also going to be when I do a full rotation back to that spot. So my angle of 0.767 gives me that cosine, but also 2 pi, if you add 2 pi to that angle, 6.28, that will also have a cosine of 0.72. And I can do that however many times I want. So I'm going to just put k here, k being an integer. So I could do that. I could add 2 pi 3 times or negative 2 times, and that will still come out to the same cosine. The other angle of 4.712 has the same situation. We could also add 2 pi to that angle however many times we want, and we will end up with the same cosine. Okay, if you are an academic, then you are done with the video. Honors kids, I'm going to continue with the 4 questions. Okay, these questions are a little bit trickier because we're changing the period. So the first thing actually I'm going to do is just to get this negative away by dividing both sides by -1. So really it just ends up being 0 is the cosine of 2 theta. Now remember our general trig equation. This 2 times theta is in the wrong spot. It should be theta over 1/2, which means a equals 1/2. And that affects the period because the period is 2 pi times a. So our period is pi, or 180 degrees, however you want to look at it. So now let's replace this 2 theta with x. So we're going to say 0 equals cos x. And then we're going to take the inverse cosine of 0 to get x. And our calculator will give us 90. Now remember with the circle that, of course, 90 is true, that the cosine is 0, but then also 270 is true. Okay, now that we've found all the solutions for x between 0 and 360, we can go ahead and substitute in our 2 theta for x. So 2 theta equals 90, which means theta is 45. And 2 theta equals 270, which means theta is 135. Now don't forget that we have to find all possibilities. With a period of pi, that means we're going to have 4 solutions. Let's think about this for a second. If the period is pi, that means I have a full cosine wave between 0 and pi, and then another one between 0 and 2 pi. And how often is the value 0? 1, 2, 3, 4 times. So I have 4 solutions. The way to find these other solutions is to add the period, but we're adding the new period of pi. So I can add 180 and get 225. Add 180 and get 315. So our 4 solutions are 45, 225, 135, and 315. Okay, Number 18 is a strange question, so it's a good one to go over. The first thing we're going to do is get sine alone by dividing by -3 on both sides. So we have the sine of 4 theta equals -2. Now let's replace 4 theta with x for a second here. Sine of x equals -2. And whether or not we replace it, it really doesn't matter because no angle is going to have a sine of -2. That's why there is no solution in this situation. Because when I take the inverse sine of -2, I'm going to get an error. So the answer here is no solution. Okay, let's think about 19 for a second. Starting by dividing by -3 on both sides. So I have 1 equals the tangent of -3 pi. So A, remember, is 1/3 because moving that 3 to the bottom makes it 1/3. So A is 1/3. And the period of tangent is normally pi, so instead of multiplying 1/3 by 2 pi, I multiply it by pi. So my new period is pi over 3. Now that means that is 60 degrees, and I can fit 60 degrees 6 times in 360. So if you picture a tangent, can't even draw them all. Between 0 and 360, you're going to have 6 of those branches. So you're going to hit 1 6 times. Okay. So we know we're looking for 6 solutions. All right, now we're going to replace the -3 theta with just x. And let's do the inverse tangent of 1, and we get 45. Now we know on the unit circle that if I have 45, then I also have this 45 right here, so 225. So my two answers are 45 and 225. Now, those are all the solutions between 0 and 360. So once I'm done finding those for x, now I can go ahead and sub back in for x. So -3 theta equals 45. So theta is -15. And -3 theta equals 225. So theta is -75. Okay, so this part of the answer is going to require a little bit more space. Basically, I'm going to be adding the period to these two answers to find out how many I can. So let me just get to a blank slide here. Okay, so we have -15, and we had -75. Those were the two answers for theta. So now we're going to start adding 60. So if I add 60, I get 45. So there's another answer. So actually, -15 doesn't count because it's not within between 0 to 360. So 45 is my first real answer. Now I add 60 to that. I get 105. Add 60. I get 165. Add 60. I get 225. Add 60. I get 285. And add 60. I get 345. And that's all I'm going to get before I hit my limit of 360. So 345 285, 225, 165, 105, 45. 1, 2, 3, 4, 5, 6. I've already got all 6. And that makes sense because if I look over at the 75 and start adding 60 here, I'm at negative 15, and you see I'm right back where I started over there. So that's not going to yield any new solutions. So those are my 6 answers right there. Okay, let's look at 20. So in 20, we have a lot of stuff going on here. So the first thing we're going to do is we're going to just add 1 to both sides. So one thing you might recognize here is that 1 is 2 over 2. So when I add 2 over 2 to this concoction, this is going to go away. So we're going to have root 3 over 2 equals the sine of theta over 4. So A is 4. It's already in the right space. So my period is 2 pi times 4. My period's going to be 8 pi. So let's think about what that sine wave looks like. So one wave is 8 pi. So here's my 4 pi mark. And this would be 2 pi right here. So between 0 and 2 pi, how many times is the value root 3 over 2? It's only going to be 1 time. It's just going to be this 1 time right here. So the question is, what is that answer? Okay, so we're going to replace theta over 4 with x. So we're doing x equals the inverse sine of root 3 over 2. And we get 60. Now we can branch out into our 2 solutions, or sorry, our 1 possible solution. Oh, sorry, again. Let's think about 60 for a second. Let's find all the possibilities for x. So where else is the y the same? Quadrant 2. And in quadrant 2, that 60 is actually 120. So 60 is an answer for x, and 120 is an answer for x. So theta over 4 equals 60, and theta over 4 equals 120. So that means that theta is 240 in this case, and theta is 480. Okay, so the 240 obviously works. That's between 0 and 360. But the 480 does not work because it's not between 0 and 360. And the period being 8 pi, which is 1440, adding or subtracting 1440 isn't going to help put it in that 0 to 360 range. So that's why 240 is the only answer here. All right, I hope this video helped you. And you can watch it as many times as you need to. And if you have other questions on the worksheet, you can ask me next time.